I'm Chaitanya. Today I'll be explaining how to download Vivado, which is a software used to program your FPGAs, and how to create a small project which uses both processing system and the programmable logic of a PingZDU board. I'll be using the PingZDU board which I have with me. Let's open Vivado. First, I will show you how to download Vivado. Open any browser. In the browser, you can search Vivado download or Xilinx. You can go to the Xilinx website. The Xilinx website appears here. Here you can see the version. You could download whatever version you need. I am using Vivado 22 or 2022.2. You can download the latest one here from here. It is compatible with all the operating systems. After downloading it, you need to install the software. It requires around 60 GB of the disk space. After installing, open Vivado. The Vivado GUI looks somewhat like this. Here you have multiple options. One is the create project options, which you need to select when you want to create a new project. One is the open project option, which helps you to open the existing projects. One is an example projects, which has the default example projects present in it. These will be available after downloading the Vivado. Now I'll go to create project. Next, give any location you want. I will create my project on the desktop. Give it any name as you wish. I'll give sample project. Click next. Okay, already a project with the name sample project exists. I'll give project one. Next. Go to next. And you need to select the board which you will be working on. I'll be working on the PingZDU board. If your board is not visible here, you need to download the board from the internet. You could just download it from the reference manual. You could go to internet and search PingZDU board documentation. Open the first link, development board. Yeah, here you could select download the board files, and also if you want, you need to flash the SD card with the operating system you need to work on. That also you could download it. After downloading it, here you could see that PingZDU image. After flashing the SD card with the operating system, you need to insert all the SD card and the cables to your PingZDU board. Finish. Today I will be creating a small project which takes two inputs from the processing system of the Zinc board and does logical operations to those input. Like it will take two inputs A and B and do and or and XOR to this input and display this output on the board and as well as on the PSGPIO. I will be using GPIOs to communicate with the processing system of my board. Now let's create a design source. This is where you write the logic for your programmable logic. Create a file. Say logical operation. Logical. Click OK. Click finish. Open the code. Now this block has two inputs, input A and B, and three outputs. XOR. And I will directly assign these outputs. The programmable logic is ready. Now you're going to save this. If you want to run the simulation, you need to have a test bench for it. Right now, I am not going to test my design, so I don't need a test bench and I'm not going to run the simulation step. But if you have any test bench and do you want to test your design, then you need to run the simulation step and see the results in the waveform window which will pop up. Now next we'll directly go to the synthesis step. Before going to synthesis step, we need to create a block design which will help to communicate with the processing system of our design. Of So for that we'll create a block design. I am creating a block design because that will be easier to than the code. Block design will be easier than the code. Click on add an IP block. Search for zinc ultrascape plus mpsog. After this, you also need to add your module here. And this IP block has many ports which are not required, so I will be removing all those ports. We don't need fabric reset enable. We don't need this port. We also don't need an output clock which will be present. And we need GPIOs. There are two types of GPIOs. One is GPIO extendable MIOs and one is GPIO MIO. These GPIO MIOs are fixed, means they can't be assigned to new variables. Like if you could see in UART, if I enable UART, it uses these MIO GPIO pins. So these GPIO MIO are fixed for certain tasks and which can be only used for that task. Whereas this GPIO EMIO can be used for many other tasks. Like I could take use of this GPIO EMIO and give my programmable logic input and output via processing system. So for that I'll be using because of that I'll be using GPIO EMIO. There are in total of 96 GPIO pins. In this I don't need this many pins because my design only has two inputs and three outputs. That is overall I need 5 GPIOs. So I'll select 5. Click on OK. These are my GPIO pins. I also add my module here. This is the module. In the 5 GPIO pins I enabled, the first two are my inputs A and B, and the last three should be my outputs. Input to my programmable logic is output of the GPIO. Means we'll get these values from the user with the help of processing system that will be given to the processing system, and the processing system will give those output to the programmable logic. So output of the processing system will be the input to the programmable logic. But before we need to slice the input pins. From these 5 bits, we only require the first 2 bits. So for that, I will be using the slice block. I need to reconfigure that. My DN width is 5. I'll be slicing from 0 to 0. That's it. And I need another size block. Here my DN width is 5 and I'll be slicing it from 1 down to 1. Connect these ports. This is A, which will be given to A. This will be given to B. And now these three output ports should be given as input to the GPIO. Before we give these three as input, I need to concat 2 bits because these 3 bits are the higher MSB bits of the GPIO. That is 4 is the XOR, 3 is the OR1 and 2 is the AND 1. 0 and 1 are my input pins. So I should not give this to the 0 bit of the GPIO. Instead, I have already taken read the output pins, so I can just give some random constant values as the lower LSB bits. So for that, I will be using a const IP block. This is let it be 0. This is of 2 bits. Oh, constant width is 2. Value can be anything. Let's say this is 0. Now I need to concat all these 3 bits. So I will use a concat IP block to do that. I need to reconfigure this. Number of ports is 4. Click on OK. Now connect these ports. Now this will be again given as input to our GPIO block. This finishes the block diagram. And if you want to see these outputs on the FPGA, you need to set these as output poles also. So I'll also do that so that you could see the output on the FPGA also. You need to set the direction as output here. Set the direction as output. Create port. Now you connect these 3 ports accordingly. And this finishes our block diagram. After finishing the block diagram, you need to create a HDL wrapper. This converts this block diagram into a HDL wrapper. This created a HDL wrapper, and also you need to set this design as the top module. This symbol here indicates which logic or which module is set as top module. After this, you run the synthesis step. Before this, you need to set the IO planning, because before running the synthesis step, you need to set the IO planning because you have defined some output ports. You need to map those output ports to some ports on the FPGA so that you could see the output on the FPGA. If you don't map, you're gonna get error in the implementation step. In order to know to what port you need to connect the output port on the FPGA, you search for the reference manual. After opening the reference manual, you could go down. It has all the output and input ports on the FPGA and their respective package pin. I want to connect these output ports, that is AND, OR and XOR, to the LEDs present on the FPGA. For that, I will go down to the LED section. Here you could see that user input output ports. This has the LED package pin. If you could see, these are the LED ports, 4 LED ports which are present, and these are the RGB LEDs present, and these are the switches. Now I want to connect my AND to B5, that is LED 0, or to ASIC and XOR to B8. In the synthesizer design also you could define the input and output ports. I will be defining the input and output ports in the synthesis step. After the synthesis is completed, click on Open Synthesizer Design. This will open the IO ports here. Select the input output standard as LV-CMOS 18. Now the AND output should be mapped to B5. Map it to B5. Our output will be mapped to A6. Map it to A6 respectively. And XOR will be mapped to B8. After mapping this, you need to save this constraint file. Give the name to the constraints file. After saving the constraints file, you need to run the synthesis step again. Click on Run Synthesis. After the synthesis step is again finished, you can directly go to the Run Implementation step. The Run Implementation step in Vivado is a process where the synthesizer design is mapped to the specific resources on the target FPGA. After the implementation step is finished, you could directly go to the Generate Bitstream step. The Generate Bitstream step in Vivado is the final process that creates the configuration file for the FPGA. While the bitstream is being generated, let's see how to turn on your FPGA. I'll be using the PingZDU board, so I'll be showing how to turn on the PingZDU board. For the different boards, you could see through the manual how to turn it on. This is the PingZDU board I will be using. Here you could see this is the SD card slot where you need to flash the image of the operating system that you will be using. This is the USB cable which you need to connect it to your computer or the laptop, and this through this you will also get Ethernet from your computer. And this is the 12 volts power supply which you need to give, and this is the power on button. When you turn it on, a green LED will turn on here, which will show that the 12-volt power supply is given to the board. And also, if you want to program your FPGA with a JTAG without using an SD card, you need to connect your JTAG wire here and also set the boot jumper to JTAG here. If you are powering on your, if you want to boot the FPGA with an SD card, you need to set the boot jumper to SD card here. The flashing of the LED indicates that the boot process has been going on successfully. A storage space will be discovered on your laptop, which says that the boot process has been going on successfully. You could see a storage space which will be discovered on your laptop. The pink USB storage space. After the boot process has been finished, the LEDs on the FPGA will blink and the done LED will turn on. This indicates that the boot process has been completed successfully. Now let's go to the browser and see how to program with the processing system. This is the website from where you could access the Pink Jupyter Lab notebooks to program your FPGA via Python. This may change for different board, but for PingZDU board, this is the URL. This is where I will be working. You could create a new folder or new notebook. Let's create a new folder, sample project. Let's create a new notebook here. Select the Python as its kernel. Name it a sample project. Sample project. Here you need to copy the bitstream and the .hwh file in order to program, in order to give it as an overlay to the processing system. An overlay is nothing but the bitstream which will be loaded onto the programmable logic by the processing system. You go to the folder where you downloaded the where you created the project and you search for the .bit file. You copy this, and you also need the .hwh file. You also copy this and paste it. You need both of these files in the processing system. So I will drag these and paste this here. You need both these files to be with the same name. After this, you start coding. You give the bitstream as an overlay to the ping board. After this, from ping, you need to import the GPIOs. You could see the which GPIO pin you will be getting. Yeah. 412 is the number for that GPIO pin 0. Like that, you need to assign the GPIO 0 pin to A and GPIO 1 to B, because in the 5-bit GPIO, the LSB bits are our inputs. So I'll be doing that. A is equal to, I need to instantiate it as a GPIO, and GPIO dot get GPIO. This is an output port, so I'll be defining it as an output. Similarly, I need to define B also like that only. GPIO pin 1, shift enter. Now you could read and write to this GPIO pin. As this is an output port, you could only read it, you can only write through it. I am writing 0 and 1. I'm writing 0 and 1 to the GPIO pins, which are input to the programmable logic. When I do this, I'm going to see expect the AND to be 0 or to turn 1 and XOR to turn 1. So let's see that what if that happens on the ping board. If you could clearly see here, LED 1 and LED 0 were turned on, which respectively mean that LED 0 is OR and LED 2 is XOR. That's what we defined, and that's what was happening actually. This means that we could give the input from the processing system. Now let's see if we could directly read from the processing system also. And one is our GPIO pin 3, which I'll define it here. This is an input port, so I need to define it as input. Similarly, I will define OR and XOR also. Those are 3 and 4. This is XOR and this is OR. After this, you run this and you could read from this and one dot read. Control enter. You could see that when A and B are written as 0 and 1, we are getting AND as 0, which is correct, OR as 1, which is correct, and XOR as 1, this is correct. This is how you could use the processing system to give inputs to the programmable logic on FPGA. This project uses both processing system of the PINZ board and the programmable logic of the PINZ board. And this is how you could create a small project which uses both processing system and programmable logic. Thank you.